Okay, these last two binomial questions are too often missed, more than I would like to say. And that's because of what we did in Goal 3.2. In Goal 3.2, when we had an exponent on the outside, we just took that power to everything on the inside. So a common answer for this first question is x squared plus 9, but it's wrong, okay? And that's because what's different about what we did in Goal 3.2 and what this question looks like is we have a polynomial. We have an addition or subtraction in the next one, okay? But we have a sum or a difference of something. All the ones that we did in Goal 3.2 were monomial terms, so that rule works with monomial terms. But think about again what I told you the power means. It means you have two of those things being multiplied together. So it means I have that. X plus 3 quantity squared means x plus 3, x plus 3. And if I write it like this, I know you'd FOIL it. But when I write it like this, people forget to FOIL it. So no, I'm starring these questions that people miss these because of that rule that we've already used. But it is a FOIL, okay? So if you need to write it twice, then write it twice, and now I'm going to FOIL it. First times first, outer times outer, inner times inner, last times last. So yeah, I'm getting the x squared plus 9, but I would be missing those outer inner terms if I took the shortcut that I really can't. That question has a specific name to it. It's called a binomial square. Not important to know, but when you have a binomial square, you do end up with the same outer and inner terms. Okay, not important to really know that though. Okay, likewise on this next one, 4x minus 1 squared quantity means I have two of those. This is a FOIL question. So I have first times first, 16x to the second, outer times outer minus 4x, inner times inner minus 4x, last times last positive 1, and again my outer and inner terms can be combined together. Negative 4 makes negative 8x. Okay, question on anything with the FOIL. Anything with FOIL that you want to ask about. Okay, remember, as I have typed here in red, that FOIL only works for multiplying two terms and two terms. But that FOIL still was just really distributive property. So when you have polynomials that are bigger than two terms, something like this, a 2 times a 3, okay, you can't use FOIL. But we're just going to use our distributive property. We're going to take our x and we're going to distribute it to the entire second parentheses. And then we're going to take our negative 4 and distribute it to the entire second parentheses. And then we're going to put the terms together. I don't typically teach this in columns. I know some of you may have learned something like that to do it in columns. The book may give you directions to do it in columns. I don't do that. If you do that and like to do it and want to do it, you can. If you don't know what I'm talking about, then don't worry about it. Okay? All right. So I'm going to start with my x. So x times x to the second is x to the third. X times negative 3x is negative 3x squared. X times positive 8 is positive 8x. And now I'll go back and I'll do the negative 4. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 3x is positive 12x. And negative 4 times positive 8 is negative 32. And then we look for terms that we might be able to combine together. Those can be combined, my x squareds And then my x's can be combined. I'll talk about order here in a second. So my x to the third comes down. Negative 3 and negative 4 give me negative 7x squared. Positive 8 and positive 12, positive 20. And my constant comes down. This answer is written in what we call descending order, meaning we start with our highest power and we go down to our constant term. I'm really not particular about order at this point. It's important in Goal 4, but if you didn't have it in that order, I don't care, just so you have all the terms right. Okay. This one looks different simply because I have the 3-term one first and the 2-term one second. Some people don't like that look. They like the 2-1 before the 3-1. So if that bothers you, then switch it. I'm not going to switch it. I'm going to leave it. So all I'm going to do is distribute 2x times everything, and then negative y times everything, and then positive 3 times everything. But, again, if you like the 2-term one before the 3-term one, then move it to the front. Okay? So 2x times x squared is 2x to the third. 2x times 2y, positive 4xy. And now I'll do negative y. Negative y times x squared is negative x squared y. Negative y times positive 2y is negative 2y squared. And then my 3. 3 times x squared is 3x squared. 3 times 2y, positive 6y. And if we look for like terms, there are no other x to the thirds. There are no other xy's. There are no other x squared y's. There are no other y squares. No other x squareds. No other y's. I can combine absolutely nothing in that question. So you're done. I think I just got one more. Okay, and this last multiplying one is a 3-term. Yes, ma'am. I'm sorry.
Yeah, so on the last one, you don't have to put like the squares before the 4.
No, I don't care. No. Okay, and this last multiplying one, a 3-term times a 3-term. Again, just be organized. Figure out which method you want to do that in. I'm going to go my x squared times everything, my 3x times everything, my negative 1 times everything. So x squared times 2x squared is 2x to the 4th. X squared times negative 3x, negative 3x to the 3rd. X squared times 3, 3x squared. And now my 3x. 3x times 2x squared, positive 6x to the 3rd. 3x times negative 3x. We're multiplying, don't forget, not adding there. Negative 9x squared. And then 3x times 3, 9x. And then negative 1. Negative 1 times 2x squared, negative 2x squared. Negative 1 times negative 3x, positive 3x. Negative 1 times 3, negative 3. So you should have 9 terms there because you multiplied 3 terms times 3 terms. So, and you'll notice many times when you FOIL, it ends up in kind of a descending order on its own. 2x to the 4th has nothing to be combined with. Oops. X to the thirds, we have a negative 3, positive 6. Is that all of them? That's all of them. So positive 3x to the third. And then we have x squared, x squared, x squared. So positive 3 minus 9, that's minus 6, and minus 2 is minus 8. And then we have 9x plus 3x is 12x. And then my constant at the end, minus 3. Okay, and my last question, applying this distributive property with exponents and solving. So we have 3 sets of distribution here. 3 times 2, 6x. 3 times minus 3, minus 9. Use this minus sign. Minus x times 3 is minus 3x. Minus x times minus x is positive x squared. Equals x times x is x squared, and x times 2 is 2x. If you end up with exactly the same term on opposite sides of equals, if you get exactly the same term on opposite sides of equals, they're just going to cancel out. It's like this x squared, this is exactly the same term on opposite sides of equals, so they're going to cancel. They're gone. On the left, I can collect my x's and get 3x minus 9. On the right, I have left that 2x. And then I would subtract my 3x. So negative 9 is negative 1x, and divide by negative 1. And x is a positive 9. Okay. So, before we leave today, I want to go through these answers. It's that right there. The 17. Okay?